China's space program has undergone a remarkable transformation over the decades, evolving from secretive inland bases to cutting-edge maritime operations that are reshaping global space exploration. This shift highlights not just technological progress, but also strategic adaptations to geopolitical realities and growing ambitions in the cosmos. To understand the rise of sea-based rocket launches in China, we must first trace the roots of its space infrastructure, which began in the turbulent era of the Cold War. The foundation of China's space efforts was laid in the 1960s and 1970s during the Third Front Campaign, a massive initiative to relocate military and industrial assets inland, away from vulnerable coastal areas. This led to the establishment of three primary launch centers: Jiuquan in the Gobi Desert, Taiyuan in Shaanxi Province, and Zhejiang in Sichuan. These sites were chosen for their isolation and security rather than optimal launch conditions. Jiuquan, for instance, became the hub for manned missions and satellite deployments, while Taiyuan specialized in sun-synchronous orbits, and Zhejiang handled geostationary satellites. For years, these inland facilities formed the backbone of China's space journey, enabling milestones like the launch of its first satellite, Dongfang Hong-1, in 1970. However, as China's space goals expanded, the limitations of these landlocked sites became apparent. Transporting massive rockets by rail through rugged terrain was cumbersome, and the proximity to populated areas posed significant risks. In regions east of Zhejiang, for example, villages dotted the landscape, making every launch a potential hazard due to falling debris. Early rockets often used hypergolic propellants, highly toxic fuels, that ignite on contact, exacerbating the danger. A miscalculated booster stage could result in what amounted to a chemical spill or explosion near civilian areas. These concerns, combined with the need for heavier lift capabilities for projects like the Chinese space station and lunar missions, prompted a pivot toward coastal development. Enter the Wenchang Space Launch Site on Hainan Island, opened in 2016. Located on the northeast coast in the South China Sea, Wenchang represented a game-changer. Engineers had eyed Hainan since the 1970s for its equatorial proximity, which provides a natural velocity boost from Earth's rotation, increasing payload efficiency by up to 20%. But Cold War paranoia fears of U.S. or Soviet interference delayed the project. By the 2010s, with shifting global dynamics in China's burgeoning economy, the site became feasible. Wenchang's design accommodates behemoth rockets like the Long March 5, which couldn't be hauled to inland pads. It has since supported critical missions, including modules for the Tuangong space station and the Change lunar probes. Yet, even Wenchang has constraints: fixed location limits, orbital flexibility, and land-based schedules can bottleneck operations amid China's packed launch calendar. This is where sea-based launches enter the picture, marking the latest evolution in China's strategy. The concept gained traction in the late 2010s, driven by the need for resilience and scalability. The Eastern Aerospace Port in Haiyang, Shandong Province, serves as the nerve center for this maritime push. Modeled as a one-port, four-centers hub, it integrates rocket R&D, satellite manufacturing, platform development, and data processing into a seamless ecosystem. Rockets are assembled, tested, and loaded onto vessels on site, streamlining the process. China's inaugural sea launch occurred with the Long March 11H rocket from a barge in the Yellow Sea, a solid-fuel vehicle designed for rapid deployment. The H denotes Haiyang, meaning ocean, underscoring its maritime focus. Since then, successes have multiplied. The Smart Dragon 3, SD-3, developed by the China Academy of Launch Vehicle Technology, has completed multiple missions, including one from a floating platform near Rizhao, deploying 11 satellites for the GLEO-6 constellation by Geespace, a Geely subsidiary. This network aims to enhance Internet of Things connectivity, showcasing commercial applications. Private firms are also diving in. Galactic Energy's Series 1 and Orionspace's Gravity 1, China's most powerful solid commercial rocket, have launched from sea platforms, blending state innovation with market-driven agility. Vessels like the Dibao-3, Tairui, and Defu 15002, repurposed from civilian ships, provide mobile pads that can sail to international waters for optimal positioning. This historical arc, from isolated inland fortresses to dynamic sea operations, illustrates China's adaptive prowess. By overcoming geographic and logistical hurdles, it has built a diversified launch network that supports ambitious goals, from mega constellations to deep space exploration. As we delve deeper, the advantages of this approach become even clearer, positioning China as a leader in accessible, efficient space access. Building on the historical foundation outlined in the previous section, China's embrace of sea-based rocket launches isn't just a strategic pivot, it's a showcase of engineering ingenuity and operational efficiency. These maritime operations offer a suite of advantages that address long-standing challenges in space, while incorporating cutting-edge technologies that enhance reliability and scalability. As China's space sector matures, sea launches are proving instrumental in supporting everything from commercial satellite constellations to national security objectives. Let's explore the core benefits and innovations driving this trend, drawing on recent developments to illustrate their real-world impact. One of the most compelling advantages of sea-based launches is their unparalleled flexibility. Unlike fixed land sites, mobile platforms can be repositioned in international waters to optimize mission parameters. For equatorial orbits, which benefit from Earth's rotational speed, platforms can sail closer to the equator, boosting payload capacity by up to 15 to 20% compared to higher latitude launches. This is particularly valuable for geostationary satellites or interplanetary probes. The Eastern Aerospace Port in Haiyang facilitates this by serving as a staging ground for vessels like the semi-submersible Tairui or the Dibao-3 barge, which can be deployed to precise coordinates. For instance, in a recent mission, Arianespace's Gravity 1 rocket launched from a sea platform off Haiyang on October 11, 2025, placing 3 satellites into near-polar orbits. This demonstrated how sea mobility allows for tailored orbital inclinations without the geopolitical hurdles of negotiating foreign launch sites, issues that plague land-based operations in politically unstable regions. Efficiency is another key edge, amplified by technological advancements in rocket design. Solid fuel rockets, predominant in China's sea launches, are preloaded and require minimal on-site fueling, enabling rapid preparation and deployment. The Smart Dragon 3, SD3, capable of lofting 1.5 tons to a 500-kilometer sun-synchronous orbit, exemplifies this. Developed by the China Academy of Launch Vehicle Technology, it uses a 4-stage solid propellant system that's storable for months, ideal for maritime environments where weather delays are common. Similarly, the Long March 11H, with its ocean-specific adaptations, has conducted multiple sea missions since its 2019 debut, including quick turnaround launches for responsive satellite deployments. Innovations like automated stabilization systems on platforms ensure steady conditions amid waves, using dynamic positioning with water jet thrusters and GPS-guided anchors. These tech features, honed from offshore oil rig designs, maintain platform stability equivalent to land pads, even in rough seas up to Category 5 hurricane equivalents. Safety enhancements further underscore the appeal of sea launches. Inland sites like Zhejiang have historically risked debris fallout near populated areas, a problem exacerbated by toxic hypergolic fuels and older rockets. By shifting to sea, China minimizes these hazards. Spent stages plummet into vast ocean expanses, far from human settlements. This not only reduces evacuation needs, but also aligns with international space debris guidelines. The transition to cleaner solid fuels in rockets like the Gravity 1, now the world's most powerful solid commercial booster, further mitigates environmental risks. Orionspace's recent barge launch in the Yellow Sea, carrying 3 satellites for commercial clients, highlighted this safety profile, with no reported incidents despite the rocket's massive thrust. Moreover, sea platforms incorporate redundant systems, such as dual command vessels for control and monitoring, ensuring mission continuity even if one encounters issues. Capacity and resilience round out the strategic perks, addressing bottlenecks in China's bustling space agenda. With 4 land-based centers, Jiuquan, Taiyuan, Zhejiang, and Wenchang, handling over 60 launches annually, sea platforms act as virtual extra pads, alleviating scheduling pressures. This is crucial for mega constellations like GSpace's GLEO-6, which requires frequent deployments for global IoT coverage. The one-port, 4 centers model at Haiyang integrates R&D, manufacturing, and data processing, creating a vertically integrated pipeline that cuts turnaround times from months to weeks. In terms of resilience, mobile platforms provide redundancy against disruptions. Natural disasters, like earthquakes in Sichuan affecting Zhejiang, or hypothetical sabotage, won't halt operations if sea assets are available. Solid fuel tech enables launch on demand, vital for military applications such as reconnaissance satellites. A notable example is CAS, Space's planned Kinetica 1 sea launches from the East China Sea in 2025, marking the firm's entry into maritime operations and boosting overall national launch cadence. Technologically, China's sea launch ecosystem is bolstered by private sector innovations, blending state resources with entrepreneurial speed. Companies like Galactic Energy, with its Series 1 rocket, and Orionspace have adapted civilian vessels into sophisticated platforms, incorporating AI-driven telemetry and real-time weather analytics. The ZQ-2E launch in July 2025, deploying 6 satellites from a commercial barge, showcased tile-shedding tech for thermal protection, a nod to reusable advancements elsewhere. These efforts are supported by government incentives, fostering a hybrid model that accelerates progress. Overall, sea launches enhance China's space autonomy, reducing reliance on fixed infrastructure and enabling a more agile response to global demands. As impressive as these advantages are, sea-based launches aren't without hurdles. While the advantages and innovations of China's sea-based rocket launches paint a picture of unstoppable progress, this approach is not without its share of controversies and hurdles. As of October 14, 2025, with recent missions like the Gravity 1 launch from a sea platform off Haiyang on October 11th, deploying 3 satellites and solidifying Orionspace's role in commercial space, these operations continue to draw global scrutiny. Critics point to environmental risks, geopolitical tensions, and economic questions, even as the U.S., led by SpaceX, ramps up its own offshore ambitions. This section examines these debates, weighing the challenges against international comparisons to provide a nuanced view of sea launch's place in the modern space race. One major controversy revolves around the dual-use nature of sea-based platforms, blurring the lines between civilian and military applications. Solid fuel rockets like the Smart Dragon 3 and Long March 11H, optimized for rapid sea deployments, mirror technologies used in ballistic missiles. For instance, the ability to launch quickly from mobile vessels in international waters raises concerns about potential military advantages, such as surprise satellite deployments for surveillance or anti-satellite operations. This has fueled tensions amid U.S.-China rivalry, with Western analysts arguing that China's civil-military fusion strategy integrating commercial tech into defense could destabilize space security. The Eastern Aerospace Port's integrated model, supporting both state-owned enterprises and private firms like Galactic Energy, amplifies these fears. A July 2025 ZQ-2E launch by Landspace, which shed thermal tiles mid-flight while orbiting 6 satellites, sparked online debates about reliability and whether such tests mask military R&D. Environmental groups, meanwhile, challenge the narrative of harmless ocean debris. While sea launches avoid populated areas, rocket remnants and unburned fuels can pollute marine ecosystems, harming wildlife and contributing to ocean acidification. Recent missions, including CAS Space's planned Kinetica 1C launches from the East China Sea, have prompted calls from organizations like Greenpeace for stricter international regulations on maritime space activities. Geopolitically, China's focus on the South China Sea and Yellow Sea for launches ties into broader territorial disputes. The Wenchang site on Hainan, central to heavier missions, sits in contested waters where overlapping claims with nations like Vietnam and the Philippines heighten risks. A surprise Long March launch of the Xian-31 experimental satellite just yesterday underscores China's opaque scheduling, which some view as assertive posturing. This opacity contrasts with more transparent Western programs, but invites accusations of non-compliance with space treaties, potentially escalating arms race dynamics. Challenges in implementation further temper enthusiasm. Startup and operational costs remain prohibitive. Retrofitting vessels like the Tai Rui or Defu 15002 demands millions, far exceeding landside construction. Logistics compound this, requiring dual ships for launch and command, plus crew quarters, stable communications, and weather-resistant tech. Rough seas can delay missions, as seen in past postponements, and technical glitches like the ZQ-2E's tile issues highlight engineering hurdles in maritime environments. Economically, low pricing for sea-launched rideshares, often undercutting SpaceX's Falcon 9, raises eyebrows. Analysts suspect heavy government subsidies or investor influxes prop up these ventures, distorting global markets and sparking trade complaints. Without sustainable profitability, some predict a bubble burst, especially as private players like Orionspace scale up amid volatile funding. Turning to comparisons, China's lead in active sea launches over a dozen since 2019, with the latest Gravity 1 marking a milestone stands in contrast to slower U.S. adoption. Yet, SpaceX is closing the gap. Initially pausing its Phobos and Deimos platforms in 2022 to prioritize Starship development, the company has revived the project. As of July 2025, crews in the Gulf of Mexico are finalizing construction on these repurposed oil rigs, named after Mars moons. These semi-submersible behemoths, with 73 by 78 meter decks and hurricane-resistant designs, aim to support Starship's massive scale, enabling equatorial launches and rapid reusability. Yesterday's successful Starship Flight 11 from Starbase in Texas tested key systems, paving the way for potential sea trials by late 2025. SpaceX's updates indicate over 100 Falcon launches this year, but Starship's offshore pivot could multiply capacity, addressing noise and regulatory issues at land sites. Unlike China's state-driven model, SpaceX's private innovation emphasizes reusability, potentially outpacing Beijing in efficiency. However, environmental reviews and FAA approvals have delayed U.S. progress, highlighting bureaucratic contrasts. In summary, China's sea launches embody bold ambition but invite valid critiques on ethics, sustainability, and fairness. As both nations advance, China with its integrated hubs and the U.S. with reusable giants, the global space landscape grows more competitive. This evolution not only democratizes access, but demands collaborative norms to ensure peaceful, equitable exploration. Whether sea platforms become the norm or a niche remains to be seen, but their impact on humanity's cosmic future is undeniable.